All right, good afternoon, ladies and gentlemen. Welcome back to another live stream. TGIF. Hope you all had a great week. It went by pretty quick. I can't believe we're already, 8 days removed from Thanksgiving. I hope you all had a great Thanksgiving. Did we do a stream last week? I don't think we did. Or maybe we did. I don't remember. But anyway, we're back with another stream this week. Back with another drink. I'm trying to cut back on my soda intake here, so except I'm clearly not doing a great job. So I got my big Coke Zero there, but I do have my water over here as well. Hope you all have brought your favorite drink as well. And let's go ahead and get into the stream today. So today's going to be a little bit different than what I normally do. Normally, I am, pretty knowledgeable about a specific topic, and then I take it through like a specific project to see like how we might apply it to that project. So like, we've been working through the movie ratings model, and then I've been showing like how you do like feature engineering and like other things. And so usually those are skills that I already know how to do. Today we're going to be doing something a little bit different. We are going to be looking at a tool that I've been interested in, but I have actually not tried out myself at all. So I actually know next to nothing about this. So as the title alludes to, we're going to be covering this open source feature store tool. Oh my gosh, that's a mouthful. An open source feature store tool called Feast. So Feast obviously standing for feature store, FEA being feature, and then ST being store. Wow, I'm just all sorts of tongue-tied today. So and so the reason I chose this tool is because, well, honestly, I don't know of any other open source feature store tool. But the little that I do know about this one, I believe it was started out of Google because Google starts a lot of the open source products, and then they eventually become kind of their own thing. I may be wrong on that, so don't quote me on that. But I do know that one of the primary creators of of Feast was hired on by another company called Tekton. And Tekton is this vendor product that is a feature store tool as well. I honestly don't know how much like Tekton is using Feast as like a backend. And so, for my coworkers out there that work with me, that we are actually starting to integrate Tekton within our own company. However, I get the sense that it's probably more of like an enterprise level usage. So like when I think about something like Terraform, so I use at home, I use Terraform, and then for like cloud to like if I want like HashiCorp to manage my TF state file and stuff, I use Terraform Cloud, which is like it can be a free tier offering, which is what I use. But then they also have something called Terraform for Enterprise. Terraform for Enterprise is fantastic for large companies, and not like it's not really necessary for somebody who like me, who's just like an average practitioner. So like I'm not going to be covering Tekton here for sure because that is a paid product. But I do wonder how much of this would suffice for like Feast, that is, being for like small company level usage or even just personal usage. So before we jump into Feast, let's talk a little about what is a feature store. And I think I've talked about this before, but it's good to recap this as we move into here. So when you think about whenever we're creating our features for a predictive model, so a reminder, what is a feature? A feature is basically a lot of people say it's like synonymous with like a data attribute or a data element. So it's basically like, with our Titanic data set, we had a number of different features associated with that set that help predict the survivability of the person. So like the person's gender, the person, like where they embarked from, their ticket, like what sort of class they were in, things like that. So those are all features. And so what a feature store is so whenever we get like something like our raw data, we massage we do exploratory data analysis appropriately, and then we massage our raw data into something that's more usable. So again, thinking back to like the Titanic data set, I think it had. So I think I mentioned the embarkation point. So that's where these ports were, like the people left. They were encoded as like SR or CI, and I can't remember what those stand for, but like they were each like 3 different city names. So like by default, a machine learning algorithm cannot use those values because a machine learning algorithm relies on numbers, of course. And so that's where we do things like feature engineering to get basically from point A to point B. So we have our raw data set, and then we do our feature transformations, and then we use them within a predictive model. So obviously that can be an extremely time-consuming process. And let's say you are building a number of different models, and many of them are using the same feature over and over. Obviously, you don't want to have to reinvent the wheel every time somebody wants to do the feature transformations, because the feature engineering itself can be quite the process in and of itself, because not only do you have to decide like how you're going to appropriately engineer the feature, but then you have to write the code and stuff too. So the idea of this feature store is, you have people collaborating together on, a bunch of different raw data sets, and then you want them to be reused as these like curated features across these different models. So what you do is you put them up into a feature store. And so this is the part where I'm going to get a little bit, we're going to learn together on how this is actually implemented. I don't know if it's necessarily a hard-coded thing, like where you just put like hard-coded features up into the features, or not like hard-coded, what's the word I'm trying to say? Like the actual data. Like, so I don't know if you're actually putting the clean data over and then like it's doing like a daily transform for those features or what, or if it's just like a soft logic. Like let's say like, okay, I have this data set and I look inside the feature store and then it's got the logic for how you do the transformation, and then I can do the transformation on the fly. So I don't know how that works. I don't know, so I mentioned Tekton earlier. I actually don't know much about Tekton at all yet. It's a thing I need to learn. But I figure, you know what, it'd be fun to check out Feast together. So with that, I will go ahead and start sharing my screen. And so, by the way, I don't know how long this stream is going to go today. My dad is coming over in about an hour to help me measure some stuff for my house, because I'm trying to... so this house is kind of goofy. It's got 3 levels: a basement, main level, second level. And... all 3 floors share the same air conditioner and heating, but the air conditioner and heating kind of come out from this furnace and an air handler here in the basement, and so the second floor actually does not get climate control weld. So like in the summer it gets really hot and it stays kind of hot even with the air conditioning on, and in the winter it gets kind of cold, to the point where like my daughter's rooms, like we have to keep space heaters on in them. So that's what my dad, he is an HVAC specialist for a living, and so he's coming to help me measure stuff so we can put in another heater air conditioner thing, so then it's not so bad for my daughters and myself. You all didn't care to know that, but I always think it's fun to like personalize these streams a little bit. Oh, also speaking of personalized, let me go back to my shirt here. So I got my Mario Christmas sweater. I kind of forgot I own this. Well, it's not really mine. It's actually, I don't know who gave it to her, but this is actually my wife's. But I stole it from her. So, but the fun thing you can see is, so she got me this little Christmas tree behind me, pointing to the Christmas tree, and so the star on here is like the Mario star, if I can point right. So it's kind of fun. You can see that, you got Mario. And then we have my Mario amiibos here. So I got this one. This is like the original Mario colors. And then this one was originally packaged with the Wii U for like a special game. And I had already owned a Wii U at this point. So I actually imported this guy from Japan. So he's pretty cool. I have both of those. Oh, and also, if you're curious, I also have the Link variant. Ooh, look at that. He's hanging out underneath my webcam here on my other shelf. So, again, more personal stuff that you probably didn't care to see, but, it's fun. All right, let's go back to the feature store Feast stuff. Okay. Oh, by the way, one quick question, if anybody is out there and is familiar with these streaming services. So I have this thing called... Like you might have seen that I do the countdown timer. This tool helps me to do that, but what I need to do is I need to start the timer manually on a scene transition, and then you can see where it starts the countdown. If anybody knows how to trigger this on a scene transition, specifically in Streamlabs, reach out to me, please, because I have no idea how to do that. So thank you very much in advance. All right, so let's go ahead and open up our browser. I personally like to use Safari. Just cause. All right, so what we're gonna go do is go to feast.dev, and so just to be really clear, the most I've looked into this at all is just just looking to see that they had a tutorial. Like that's about it. So let's just look at this homepage real quick. Let's go ahead and zoom in on this. All right, so it looks like we have some stuff, stream sources going into Feast from both batch sources and stream sources, and it looks like that it supports a number of different sources. So, if you're not familiar with some of these terminologies, so BigQuery is a Google Cloud Platform product. Redshift and S3 are AWS products. I'm not sure what GCS is. Kafka is an open source streaming tool. Kinesis is AWS's thing. Parquet is just a file format. And so you can see that, we got a couple different things in here. We got the store, transform, serve, validate, and monitor. I don't know what any of this stuff is doing, but we'll find out together. One other quick thing to note. So I am streaming on both LinkedIn and YouTube, and I have both chats open. So if you have any questions, regardless of what platform you are on, I have both of the chats open, and please feel free to drop in a question, and I'll see if I can do my best to answer it. Okay, so it looks like the data scientist here is able to search and discover for features, put new features back in, and is able to. Well, it looks like I see two different arrows here. One, I'm not sure what this arrow is supposed to be doing, but it looks like, obviously this arrow is, if you wanted to, I've toyed with this idea of creating like an open source ML ops kind of product too, which is why I'm exploring this thing, Feast here today. And we'll see more about that in future. But anyway, it would make sense to me that if I did that, then you'd want to have an automated way to actually get the features out of the feature store, aka Feast here. All right, so engineer, build server that fetches features. Okay, so that would be something like my role. So just as a reminder, I am a machine learning engineer, and the machine learning engineer versus a data scientist. Data scientist is the one really that's creating the models. They're doing the exploratory data analysis. They're the ones doing like the feature transformations and the feature engineering to begin with. Whereas the machine learning engineer, like once the model is trained, they usually hand off that work into like my role, and then we package it up appropriately for production. So I'm going to guess that's what engineer represents here. Okay, so when I looked at, by the way, so I just went to feast.dev here to get here. So feast.dev, nothing overly fancy. So I'm going to go to docs, and because I saw the tutorials in here, and again, we are starting kind of from scratch. And the reason I kind of wanted to do this together is I saw in here that there was an opportunity to run this as part of Google Colab, which means that we are all going to be on the same footing together. There's no, if you are just joining the stream, do not worry about, I'm hoping to say, do not worry about having anything set up. It looks like we're going to be able to do everything in the browser. So that's really, really cool. Okay, so in this tutorial, let's go ahead and zoom in this. We are going to deploy a local feature store with our Parquet offline store and SQLite online store. Okay, I don't know what online versus offline means in this context, so we're going to learn that together. Building a training data set using our time series features from Parquet files. Okay. Materialize feature values from the offline store into the online store. Again, don't know what offline store and online store refers to here, but we shall learn. And read the latest features from the online store for inference. Okay, so we are going to go ahead and click this button here, and we'll see how much of this we have to do. Let me do a quick sip of my drink here, and we shall continue on. Okay, so first things first, we need to do a pip install of Feast and, all right, warning, this notebook is not authored by rights by Google. That's fine. So let's go ahead and run this. So I actually have not used Google Colab that much. So like I've been a machine learning engineer for now 2 years. And when I did all my learning like back in 2019, Google Colab, I mean, it might have been a thing, but I didn't really know about it. But it looks really cool. From what I'm checking out here. So basically this is kind of more or less a Jupyter notebook. I know it looks really different, but I think that this is what it is. But so all this is running directly in the browser, which again, I'm hoping that whatever device you are watching the stream on, you should also be able to follow along if you would like. Okay, all right, so we have finished doing our install, I think. Please restart your runtime now. So runtime restart. So let's do a runtime restart. Runtime. Okay, this ensures the correct dependencies are loaded. Okay, so we did that. Boom, step 1 complete. All right, so we're going to create a feature repository. A feature repository is a directory that contains the configuration of the feature store and individual features. This configuration is written in Python YAML code, blah, blah, blah. You can all read this for yourself. All right, so the easiest way to start a new feature store or feature repository is to use the feat init command. All right, so I guess we're going to go ahead and run this command. So by the way, in case you are not familiar with kind of like how Jupyter does things, so like if if you have this exclamation point right in the beginning of here, this is basically running shell commands. So if like I was doing this locally, and I actually don't have this installed on my machine at all. So I think it's a pip install. In fact, well, let me just go ahead and look to see if I was going to do this. So yeah, it's a pip install. So I'm going to do pip install feast. Feast your eyes on feast. That's what I really wanted to call this stream, but that was a little too corny, I thought. So yeah, it looks like it installs just a simple pip install. Just checking the time here. Okay, 2:15. All right, so we are going to. Oh wait, I gotta go back to here. All right, so we're gonna go ahead and run this command feast init feature repo. So it's gonna go ahead and run. Feast is creating an open source project. All right, so blah, 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 creating a new Feast repo and content/repo. Okay, very good. All right, so let's take a look at the demo repo itself. It breaks down into data, which contains our raw demo data, example.py, which contains demo feature definitions. Okay, so if I run this is basically doing an ls command, which is just basically telling us what's in the contents of this this repo up in here. So it's saying, okay, under this feature repo, we have the data directory again. Okay, yeah, all three things there. And then underneath data, we have the Parkite file. So it looks like we're dealing with some sort of driver data. Okay, we shall learn more about that probably here soon. All right, so we are inspecting. I've never used whatever this pigmentize thing is. So let's just do Google of what this is. Pigmentize. All right, so pigmentize looks like a CLI command thing. All right, you can use pigments from the shell. All right, so tell me, what is pigments? All right, this is the home of pigments. It is a general syntax highlighter used for. Okay, so it's basically like a pretty printer. Is that what it is? That's what it seems to be. Okay, so it looks like if we run this command, so naturally it's going to pretty print this. I wonder if I just use the cat command, if this would work as well. Yeah, it's basically doing the same thing there. Okay, so no big deal. All right, so first things first, we are going to load in the data. All right, so here, again, we have a Parquet file. So by the way, in case you're not familiar with what Parquet is, a Parquet is a file storage system that supposedly stores or compresses data on a columnar basis. And the reason that's important is, let's say you're loading up a data set, but you only want. All right, so we have, what do we have here? 1, 2, 3, 4, 5, 6 features. Let's say you only wanted like the first 3 features. The way it's designed is that, like, if you wanted to load those first 3 features, you can, and it'd do it much more quickly than like a CSV file, because a CSV file, which is what a lot of you are probably typically work with, is going to like, if you want to load up the whole thing, you got to load up everything, every single feature. So that's why we, like, a lot of people are moving toward using Parquet, is because then we could load just these first 3 features, and then not have to worry about these others like bogging down our load time. Excuse me. I had Portillo's for lunch, and yeah, I need to stop eating big meals before streams, because never mind. All right, so we just inspected the raw data. So it looks like we have, a timestamp, identification thing, some sort of thing called a conversion rate, ACC rate. I don't know what that means. Oh, I didn't even see this here. The data set captures hourly stats of a driver in a ride-sharing app. Okay, so conversion rate, ACC rate. I don't know what ACC rate means. Average daily trips. Okay, and created. I don't know what created means in this context, but that's okay. All right, so next. Register feature definitions and deploy your feature store. So Feast Apply scans Python files in the current directory for feature entity definitions and deploys infrastructure according to feature store YAML. Okay, do we look at the feature store YAML before? I think we did, and I think I browsed over it really quickly, but it's probably good that we look at this a little more. Okay, so this is what the feature store YAML has. It has the name of the project, the registry. So the registry is going to be called data/registry/db, provider local, online store path, and then online store. So basically what this kind of looks like is this kind of instantiating the location of where you want your data to reside. So again, as a reminder, this tutorial is working locally. Local within this Google Colab, or if I were to literally do this locally, which, if I have the time, I may just download the data and do it locally really quick just to see how easy it is to do on my local machine. I highly doubt it. I don't even know why I said that, because I don't think I'm going to have the time. Excuse me. So basically what this is doing is, when this whole thing instantiates, it's going to put the registry in this data directory, and then it's going to put this online store also in the data directory. All right, so scroll on down back to here. Okay, all right, so let's inspect what example.py looks like. All right, so let's go ahead and run this, which it looks like all these have already been run, but I'm running them again anyway just to be safe. All right, so from google.protobuf.duration_pv2, honestly, I have no idea what this is, but I guess we'll find out. All right, so it looks like from Feast, we're importing something called an entity, feature store, feature view, file source, and value type. All right, so here we are going to be reading in, all right, I'm just trying to make sense of things here. So we're reading in the hourly driver stats from a file source. So here, again, what it looks like, just trying to explain that, talking through things out loud, I'm probably going to make mistakes here, so I apologize for that. But it looks like we are, we're loading in the same data. So this is the same data that we saw up here in this table. We are loading it from this particular file, and then we are noting that this it looks like it has an event timestamp column here. Okay, so we get to note that, and we have the created timestamp column created. Okay, I wonder if these latter two are optional. Well, let's just keep moving forward, because I'm not really even sure what the file source is going to be used for, but we'll find out here in a minute. Okay, define an entity for the driver. You can think of an entity as a primary key used to fetch features. So makes sense enough. All right, so in this case, because we are using ride-sharing data, we are going to look at the driver entity. So it looks like we're instantiating the entity known as driver from the driver ID, and we are calling it driver ID, and the value type is going to be int64. So I just want to make sure. Okay, so value type is being derived from Feast as well. All right, so now before we move forward, and I'm not looking down yet, but question number one is going to be like, how does this tie back into this, or how does it tie into our data set as a whole? Because as you can see, this is kind of its own thing. It is not connecting to anything yet. All right, so let's keep scrolling on down. All right, so our Parquet files contain sample data that includes a driver ID column, timestamps, and 3 feature columns. Here we define a feature view that will allow us to serve data to our model online. All right, so here we are creating this view. So this feature view thing here is coming from this top here. So as a reminder, we are looking at a Python file called example.py. All right, so we are getting the feature view here again from Feast. And we are noting the features of the feature store. Okay, so this isn't, well, I'm a little bit thrown off. All right, so we have the name here being derived here. Entities, we're noting entity as I wonder if it just knows. I'm a little bit thrown off here, like how it knows that this driver entity is tied to this. Like, I wonder if it's just looking for this object behind the scenes. I don't really know. Maybe. Time to live, TTL usually stands for time to live, so duration, seconds, so it's going to live for... so it looks like... Okay, never mind. Let's just keep going. All right, so the features that we're going to be putting in there are the conversion rate, I don't know what ACC stands for here. Accuracy? No, it can't be accuracy. ACC rate, so those are both going to be fill-up values, and then average daily trips is going to be an integer value. All right, so we're noting online equals true, batch source equals hourly driver stats. Okay, so this, all right, so our batch source is, this is actually pointing up to the same thing up here. Very good. And then tags. I'm going to guess that tags are going to be just like, tags on AWS. It just helps us to organize our data better. Like, I'll be curious on the other. I'm very curious if Feast has a UI, because that would make sense. Like, if you wanted to filter on a tag, like, okay, let's say like this is associated to, I know this is not, but let's say this is associated to your marketing department, then maybe you could have a tag here that says, with a key that says department, and then the value that says marketing, or maybe the value says, in this case, we're talking about driver stats. I don't know what you'd call it. Marketing was anything else other than the marketing. What other departments are there? IT, I guess. What sort of departments are there in a company like Uber? I don't know. The business department. I honestly don't know. Okay, so anyway, all right. So that was just looking at this. We didn't actually run anything. It was just using this pigmentize thing here. And I honestly don't know what terminal 16M means. I'm gonna guess. Well, now I'm curious. No, I'm not that curious. I am curious, but I don't want to spend all the time here doing. Okay, so now we are going to run this feast apply command. So what the feast apply command, let's read what we're going to do here. So now we run the feast apply to register the feature views and entities in example.py. I feel like I'm reading. So I read a lot of books for my daughters. I have 3 and 4-year-old daughters, so I feel like I'm reading all to you, kind of like you're my daughters, but yeah. So they're so sweet. Now we run feast apply to register the feature views and entities in example.py and sets up SQLite online. Online stores. Note that we had previously specified SQLite as the online store in the. Okay, so I was going to say, no, we didn't. I don't remember writing SQLite, but it says, okay, if you put local, I guess it defaults to SQLite. Oops, didn't mean to do that. Sorry about that. All right, so let's go ahead and run this. So we're going to run the feast apply. All right, so we registered this entity called driver ID. We registered the feature view, driver out early stats, and we deployed the infrastructure. All right, so let us generate the training data. I'm going to skip past this thing because I want to save my voice a little bit because, for some reason during this winter season, I find that if I talk too long in a row, then my voice kind of goes out about at the 30-minute mark, and we're approaching the 30-minute mark now. So I'm going to take a sip of water this time. Oh, I don't know if you all could see, but I'm holding a cup here. It's a stupid joke because it's a camo cup. Get it? So because you can't see it, like I know, dad jokes. All right, so so what we're gonna do in here is we are instantiating some things. Excuse me. All right, so we are going to be running this cell, which is going to be all right. So it looks like we instantiate the feature store here. All right, well, I'm skipping ahead a little bit. So it looks like we're creating some sort of entity data frame from this custom dictionary here. So it's basically saying like, okay, so date_time.now is getting the time now minus from, and then 11 minutes ago, and then 36 minutes ago, and then 73 minutes ago. And in fact, I kind of want to just print out. Yeah, I'm going to print this out. I know this is not something in here. Can I do this? I've never actually. So, totally transparent. This is my first time actually using Google Colab too. I've just, I personally, if I ever have to do any like Jupyter work, I just do Jupyter like locally. But, I'm all for anything that's going to help people learn very easily. And, so if this is going to help you get started to learn Feast here, I'm all for Google Colab, but this is my first time actually using it. All right, so I'm going to do entity df dot, I'm going to do a print entity, df dot head. Okay. All right, so then we instantiate the feature store repo, which is going to be in the same repo that we're in. So this is where I'm curious. I'm going to just sound out or talk through my curiosities out loud, and we'll see like how it gets resolved. But my one curiosity here is, so we did a local path for this, but most people aren't going to store a feature store locally. It's going to be up in, AWS or GCS or Azure. So I'm curious what this looks like if you're doing that with one of those, but I guess that's out of scope for this thing here. All right, and so then we are getting our training data frame, and to do that we are getting historical features. We are passing in the entity data frame, okay, and then we are getting these features. So it looks like it's referencing the feature view that we created and then each of the respective features, and then it transforms into a data frame. All right, so let's go ahead and run the cell just to see what happens. All right, so this first part here, this is the custom code that I added, just to show the like the original like data frame. So you can see here we got just the 3 records, and then so today is December 3rd, and I'm guessing I'm not very good at reading well, because I was going to say this is military time, but I don't even know what time zone this is because it's 2:30 local time for me, and I know that's not 2:30 local time. It looks almost like this is GMT, Greenwich Mountain Time, which is over in like what is that? The up, not the equator. You have the other one, the prime meridian. Is that what it's called? I don't remember. But anyway, so that would make sense if that was what that was. All right, and so then what we see here is we have this entity DF. Is it called entity DF? Training DF. I'm sorry, training DF. And we have 6 columns. So we have our original couple. So our original couple, we had the label, driver, reported satisfaction, driver ID, and the event timestamp. And now we have 3 new ones. And so if we did a feature head here, and we got the ... which is basically saying, oh, my big head's in the way. I just noticed that. Sorry about that. And yeah, so it looks like we did. It looks like we were able to extract the features just fine from there. Although, I guess I'm just a little bit confused on how this works. Or I wonder if it's tying back to these driver IDs. All right, so let's go back up and look at the driver data because I'm trying to make heads and tails of like how this is being associated properly. Okay, so we do have a couple driver IDs in here. And in fact, I'm going to go ahead and let's explore this data a little bit more here. And I know that we just did the pd.read part K here, so let's actually call this DF because I want to explore the data a little bit here to understand what it's doing a little bit better. All right, so we instantiated that there, so we're gonna say DF driver ID, and then we're gonna do an equals because we have well actually let me just do a DF driver ID dot value counts here, and the reason I'm doing this here is because it looks like that there's not that many drivers in this data set, even though it says 1,000, and we have 1,800 rows here. But let's check out like how many there are actually in here. Okay, so it looks more or less evenly split between these 5 different ones. Okay, so we had those couple there. So let me scroll down to remember what I'm trying to accomplish here. So. Label driver reported satisfaction. So we have these 3 driver IDs, and then it got, well, because it added a couple different things, but I'm trying to figure out like how it knew to associate these things to a different timestamp. Because I don't know, I don't know where it got this information from necessarily, or what this was necessarily doing. So this is the one challenge with trying to work with a data. I should have previewed this a little bit more to understand like what this data set is doing. And I mean, I'm not trying to be critical of this this tutorial though, but this would be a little bit more helpful if it had information about what this data set is and what it has. Like the fact that I don't know what this ACC value is throwing me off. So I'm trying to figure out what this necessarily means. And if anybody here is watching this and has done this before, drop a comment in the chat because I feel kind of stupid right now. All right, so we have these different features. We did the feast apply. All right, where is that one area? Okay, so the value counts. All right, so let's just look at the value counts for driver ID. Or no, I'm sorry, not the value counts, but the first few rows for driver ID equals 1001 dot head. Okay, so this is for the 1001 driver set data. So I don't know. Okay, so I see an event timestamp here. It's curious because I see and they're surely not updating this on a daily basis, are they? Okay, so created. Well, I would have created that, right? When was this Parquet file created? I wonder if they're somehow behind the scenes generating this thing on the fly, whenever I instantiate this notebook. I don't know. let me take a sip here. Okay. Because I'm trying to make sense of like what it did here. I mean, it clearly worked, whatever whatever it was trying to do. So, well actually, let me just do a search on this. Like, let's see if we can find this value in the data set. All right, what was this? ACC rate. Okay, so ACC rate. All right, sorry for all the scrolling. All right, so ACC rate equals that. Well, I didn't mean to do a dot head. Equals that. Okay, so now I'm really thrown off, and I'm not even sure where we got that ACC rate from. Yeah, I am a little bit thrown off here. Okay, let's go back. All right, so event timestamp is date time minus now, date time minus now. All right, I'm guessing that it would apply something to these features, but I'm not sure what it's applying here. Like, it must be applying some sort of logic, but what sort of logic is it trying to apply here? All right, so we have the feature view, D-type, time to live, duration. I'm really thrown off here right now. And again, I probably should have read through this before, so apologies. I'm going to chalk this one up to me. I'm going to not blame Feast on this one. Although I will say, Feast, if you are watching this, please include a little bit more about like what the data is, the example data is here's doing that. I think that would help out a lot. All right, so read data from the Parquet files. Parquet can be a local data mode, blah, blah, blah. You can use your favorite data warehouse, such as BigQuery, see Feast documentation for more details. So I wonder if I can just go in here and if it would show me something better. All right, so... All right, register the feature definitions. Okay. But the feature definitions, like, so we're calling these the features, and it looks like it, well, what is this doing? Because I don't see, like, any, like, what I'm expecting to see is, like, did it somehow take these things and do, like, a transformation, because I don't see any transformation logic in here, like, and that's where that's what I kind of would have expected to see. All right, so let's go ahead and read this out. So to train a model, we need features and labels. Often this label data is stored separately. You have one table for storing the survey results and another table with feature values. The user can query that table of labels with timestamps and pass it into features as an entity data frame for training data generation. Will intelligently join relevant tables to create the relevant feature vectors. Okay. All right, so load your features in your online store. So that wasn't super helpful. Again, I'm chalking this one up to just me being dumb here. Okay, so let's come back into here. All right, feature view. Well, let's just look at the actual documentation here to understand like what is the feature view. So Feast feature view. Feature view Feast. Okay. A feature view is an object that represents the logical group of time series feature data as it is found in a data source. Feature views consist of 0 or more entities, 1 or more features in a data source. So features are used during the generation of training data sets, of course, in order to find historical feature values. A single training data set may consist of features from multiple feature views, of course. Loading features into an online store. Feature views determine the storage schema in the online store. So it looks like we are actually storing something. So feature views without entities. That's interesting. If a feature view contains features that are not related to a specific entity, the feature store can be defined without entities. Okay, so, but again, like I'm thrown off on what this is necessarily doing. So the entity here, because I want to make sure that I don't know, maybe I'm just misunderstanding this whole thing. And this may be like this may be pretty bad stream. Pretty bad stream, like, because I didn't do my homework clearly. Like, I was hoping that I could jump into this blind. And, obviously I could do this if we had enough time, but, I'm going to have to depart here in 20 minutes to help out my dad. Okay, so let's come back into here and see if I can understand this again. All right. Contains sample data, includes driver ID, timestamps, and here we define a feature view that will allow us to serve this data to remote online. Okay. All right, so we have an entity data frame is where we want enriched values with feature values. Yeah, but I don't see where like the timestamp necessarily correlates to something that is going to give us whatever this is. Well, let's just do like a search for a different kind of search up here at the top. So average data. All right. So let's change this value. And I wonder if it was because that was actually a string value or I screwed something up. Average daily trips. Okay, so here's something interesting. I wonder. Actually, let's do a quick print df.info. Get out of my way, please, and thank you. Okay, so when I look at this, okay, so it was a float value, so it's not like that was a string. All right, so I do see that we have this here. All right, so we have average daily trips. This is correlated to driver ID number 1005. Okay, and then this one's 1003. Okay, so let's go back and look at, well, because I'm thrown off again, like when this was created. I don't know, maybe I should have done this all locally. Because surely this data was not created just like 5 minutes ago. Like, and don't call me truly. Airplane joke. All right, so okay, so I guess this is gonna make sense. So 426. All right, so let's look again. 339. All right, I'm gonna take a picture of this just so I can remember it. Usually, what I do is I do a split screen but you know, since I'm streaming this here, I want to make sure that I can see this on my own phone while comparing that. Like I would actually just move this window down here, but I want you all to be able to see it as well, of course. Okay, so scroll. All right, so done scrolling yet? Yeah. All right, so 426. All right, so does that match into 339761? Hot dog, it does. So I must have just had a typo there or something. Okay, and then driver ID 1003. Okay, so it actually did work. So what it did here was, let me just show here. All right, so let's focus in on this one right here. So driver ID 1003, and then had this event timestamp, and then this label satisfaction driver of 3. And so basically what it did is when I said, okay, I had this entity I have this driver ID, it's got this stuff. Like, okay, give me the extra features that are associated to this. All right, and so what it did here was it went ahead and attached those. Now here's the thing I'm thrown off on. I thought we were. It looks like we are actually hard coding the values up into the feature store. Like, meaning that like it's not actually transforming anything on the fly. It's just enriching the data with the features based off of like the entity information. So entity information is a unique identifier, or it can be a composite key. So like a lot of the data that I work with in my work is usually a composite key of like you have like 3 different IDs, and those 3 different IDs together represent like one entity, like when they come together. And I think that's kind of what's being done here is like we have we have the driver ID, we have the label driver reported satisfaction, and the event timestamp kind of come together to do like one thing. Although I'm still really thrown off on how it knew how to do the timestamp matching appropriately, because that's weird. Like, right? I'm not nuts, am I? Like, I don't know where that really came from. Okay, but I guess it worked. So let's keep learning some more. Excuse me. We are now ready to serialize the latest values of the feature since the beginning of time to prepare for serving. Note, materialize incremental serializes new features since the last materialize call. Okay, so let's go ahead and run this cell just to see what happens. All right, so feast materialize incremental data. So, I didn't know you could do this. This is kind of cool. So what it did here was, I didn't realize that you can run shell commands, but then also have like the output of like a Python command here. So that's what it's doing here is like, we're using the Python datetime while using a shell command to pass in like the datetime format. Sorry. All right. Materialize one feature view into this, into the SQLite store. Okay. So what it looks like it's doing, and I'm guessing that, you could set this up in an automated way that would run on a regular basis, is that it is creating this feature view based on like the snapshot point in time. So I'm assuming that you can create something to where like it'll run daily, and then you can have feature views at a point in time, and that way, like let's say you want to get features from Thursday of last week, which was Thanksgiving, then you could go and do that based off of like the timestamp here. And I wonder, it's got a date here. I wonder if you could use different kind of keys instead of that. Like instead of using a date, can you use like, I don't know what I'm saying. All right. So let's keep going. All right. So now, all right, inspect materialized features. Now that their data, note that now there are online store DB and registry DB, which store materialized features and schema information respectively. Got it. All right. So it's going to, all right, let's go ahead and run this cell. All right, so it's going to print out. All right, so we have in the data directory, we have the driver stats.k, which is the file that we started with. We have the online store.db, and we have the registry.db, of course. So, we're doing all this locally, but I'm assuming that this would be stored up in one place, and then this would be stored up in another place. So, like this is kind of like your metadata store, I would assume, and then this would be the store that actually houses the data. All right, and so then it looks like we can actually query stuff directly from here using SQL. So that's kind of cool. So we're connecting to the database using SQLite 3. And then we're just doing a select star from the feature repo driver hourly stats. Is that what we named it? Like, let's scroll back and look. I just want to make sure. All right, where is that? Materialized incremental. Where do we name the feature store itself? So, okay, it looks like... Okay, so it looks like the way it stores it is it's just like the project name and then underscore like the table name, I guess you'd say. So in this case, you can see that we're doing the project name. Where are we going? Okay, so okay, so the project name here and then underscore the actual table name here. So we're passing in the connection columns.toList connection.close. All right, so then we have the entity key, the feature name, value, event timestamp, create a timestamp. All right, so quick note on entity keys. Entity keys include a list of all the entities needed to generate the feature vector. In this case, this is a serialized version of the driver ID. Okay, so maybe I have like a totally backwards understanding of like how this whole thing works. So it looks like that a feature store here is being used for feature enrichment. So like, let me try thinking of an example. Let's say I am selling I'm selling a product online, and I have a bunch of data about that product historically from like the last couple years, like as far as sales data that goes. So if I were to pass in like, and let's say there's a bunch of different products, like, and they all have their own unique identifier. Let's say, Christmas is coming up. It's toys. We are selling a bunch of toys, and each toy has its own unique identifier. Okay. So then it looks like what we could do is with the feature store here is we'd pass in the unique identifier as the entity key, and then that would enrich the data that we need from the feature store to get everything that we need. So like, let's say we would have the features there would be like dollar amount sales, let's say sales tax, local sales tax. I don't know. I'm just spitballing ideas here. And so, I mean, that is really helpful, honestly. So that is really helpful to get that historical data. But it's not exactly what I thought it was. I thought it was more of a feature transformation thing. So again, I'm still learning, and I could be incorrect here. All right, so let's fetching feature vectors for inference. Okay. All right. Okay. All right. So this is kind of cool. All right. So we again are so we're instantiating the feature store here, and we're getting our feature vector, so we're doing the store.getOnline features. So we're once again getting these features, and then we are passing the driver IDs here, and then to dict. All right, so I mean, I guess the one thing I'm still thrown off about is, we have our entity rows here, but like how else, like, because, we saw like 300 of these rows for each of these respective driver IDs. Yeah. Okay, so obviously we got these things. Oh, and this is probably why it didn't work out before, because this float value is a lot longer than I thought it was. And I just gave it to the truncated float value. That's why the search didn't work. Whereas opposed like the average daily trips did work. But now I'm curious, so let's just grab. No, I'm not that curious. But I mean, it looks like it worked, but I just don't know how. We passed in the driver ID, and how did it not know to grab these specific values amongst everything that we passed in? So yeah, I am curious. So let's look at getting 984 average daily trip. And my throat's already starting to give out. I don't know if you can hear that also. Probably going to have to end this again soon. All right, so we passed this in. So it looks like this was created on 12.3. All right, so it gave us which one of these. All right, I'm going to take a picture of this again. Sorry. Take a picture. Boop. All right, and now let's read here. All right, so zoom in. All right, let's scroll back on down. Scrolling back on down. Again, I wouldn't normally take pictures like this. I'd just do a side-by-side screen, but I don't. My other screens are occupied by my stream and stuff right now. And plus, I want you all to be able to see what I'm doing here. Okay, so average daily trips, 984. So that is the second value. So what is the ACC rate? 2.2. So this is the thing. Like, even though I did this query thing here, and I don't know if you can see it. So it, what is this associated to? 1005. Okay. All right, so this is associated, this 904 average daily trips is associated to this driver ID of 1005. And then you could see the ACC rate there. I don't know if you can see that well. Does not match. Like, it does not match this, what I'm saying, what I just highlighted right here. And I don't know why. So yeah, I don't think I'm gonna do another stream like this in the future, because this just didn't come out as like I don't know. I guess I need to read the documentation more on to understand this. All right, so read the concepts page to understand the feast data model. Okay, so let's see if we can just try to understand this together without trying to do the tutorial. All right, so overview. All right, so top level namespace of a feast is a project. Users define one or more feature views within the project. Each feature view contains one or more features. These features typically relate to an entity, of course. A feature view must have a data source, of course, which in turn is used during the generation of training data sets and when materializing feature views into the online store. So all right, so I'm trying to think through this in my head. So we loaded the original data from a Parquet file. We put that Parquet file into the feature store with the feature store apply, the feast apply command. And that associated, well, we also had an entity in there as well. That tied the entity to the features from the data source. Okay, good there. Moving on. Data source. All right, so the data source refers to the underlying data. Feast uses a time series data model to represent data. Okay, this data model is used to interpret feature data in data sources in order to build training data sets, or when materializing features into an online store. Okay. Below is an example. All right, so we have the timestamp here, of course. I don't remember what the timestamp here is correlated to. Is that when the data is loaded into the feature store? 5/22, that's my dad's birthday. How coincidental. And then we have the entity values and the driver values. So these are the same driver IDs that we saw before, and then like the feature value. All right, boom. I think I'm good with that. Let's go ahead and keep going. Entity. Entity is a collection of semantically related features. Users define entities to map to the domain of their use case. For example, a ride hailing service could have customers and drivers as their entities, which which group related features that correspond to these customers and drivers. Okay, so we have the, we saw this before. And then the entity key here. Okay, so entity key can be synonymous with a composite key here, because it looks like this is a composite key. So like sometimes the key can just be like the driver ID by itself, but in this case it is referring to the driver ID as it correlates to the customer ID. So like let's say I'm a driver and my wife's name is Maggie, she's the customer, so my driver ID would be like 1001, and I'm driving customer A Maggie. I drove her 5 times today, and really? Wow. What? Maybe I'm misunderstanding what this means, but the way I'm reading this is customer A went with driver 1001 on 5 different trips. I'm gonna guess that they didn't take 5 trips in the same day together. Like, again, so this is where, okay, my only criticism of this tutorial so far is like I wish I understood what like this data meant better, because I don't really understand what the trips today means, because I highly doubt customer A is going on 5 trips with driver 1001. Like that would be so weird. Like imagine going to Chicago or something, or some big city, and you got an Uber, and you, for some reason, who's taking 5 Ubers a day anyway? Like let's say you take 5 Ubers and you have the same driver all 5 times. What's the probability of that? 0. Or next to, like, close to 0. So okay, I'm lost, but let's keep going. All right, so a feature view is an object that represents a logical group of time series feature data as it is found in a data source. Features consist of 0 or more entities, 1 or more features. All right, so apparently I just had like a bad understanding of what a feature story is, because this is not what I thought it was. Or maybe I don't know. Like I could. This is one of those times where when I am going to admit here that like I could be totally wrong about everything I said here, and it looks like that's the case. Like that whole introduction, I may have just botched totally. I thought that's what a feature store was, at least in this context, but maybe I'm misunderstanding things. I don't know. I need to take a sip of my drink. So, well, I mean, you still have your features up in here. I'm just curious of how they get populated in on a regular basis. Like, so, like, because I thought because it looks like the transformations are actually happening outside of the feature store. Like you had, okay, so coming back to here, we have the Parquet file here. This Parquet file here, so it looks like we're already starting with some sort of clean data set in the form of this Parquet file here. Like, how did we get this Parquet? Like, that's what I thought, like, we were going to be doing, is that we would be like we would have some raw data, and then it would go into this Parquet file here, and then this Parquet file here would get uploaded into the feature store appropriately. But apparently that is not done as part of Feast. I wonder if Tecton does that in some capacity. I don't know. Okay. So then features used during training, features without entities, entity aliasing, feature, alpha on-demand feature views. Okay. All right. So what is feature service? I mean, it is still really nice. Like it would, I can think it would be great, kind of like in that toy store. And I'm only thinking toys right now because Christmas is coming up. But in that toy kind of idea of like, let's say, I wanted to do an inference, but like, and the only information that I knew was, okay, I got the entity key, which would be the unique identifier, like noting the toy. Like, and if I wanted to get an inference on a daily basis about like, maybe projected sales, then maybe I could get like very easily and very quickly just pass in, okay, I got this toy. I want the last week's worth of data for my inference. Give it to me. And in that case, this is really nice. Because then I don't have to do like the special joins or anything. It's just boom, boom, boom. It's doing it all for me behind the scenes. Okay. Feature retrieval. And I think that's all what it did. And I think time joins. Yeah, so that's what it's basically doing, is doing like joins and stuff behind the scenes for you. So I mean, this still is really, really nice, especially given that this is all open source and free. But now I'm curious what Tecton does in addition to this. Okay, so I see here architecture. I'm very curious what the registry. Okay, the registry. Feature registry is a central catalog for all feature definitions and their related things. Okay, so you can do a feast feature store, and then so it looks like it is passing in a repo. But again, I'm curious because this kind of just looks like a local repo. I wonder what this would look like for like if you were on S3 or GCS here, GCP. I'm sorry. Yeah, I don't know. All right, offline store. All right, offline store stores. Feast uses offline stores as storage and compute system. Offline stores store historical time series feature values. Okay, so Feast online store. So okay, so it is actually storing data, and it can store data in BigQuery or in something like. So okay, Feast materializes getting the features on a regular basis in something like a so like this, so Redis and Firestore, those are little caching services. Okay, so that could be helpful if you need like data really quickly. So like maybe this is kind of refreshed on, hourly, daily basis. I don't know. Provider. What is provider? Provider is an implementation of a feature store using specific feature store components. Online store, uh, offline store, online store, blah blah blah. Um, okay, this makes sense. I'm just trying to think like, so what I'm trying to think through is like, okay, let's say I didn't have Feast. Like, how would this work without Feast? So what I would do is, so on a regular basis, you would have your operational data going into something like an analytical data store, like a data lake, something like that, and I would need that data transformed on a regular basis to then get stored into like some sort of source where then my inferential source can grab that. So like let's say wasn't using Feast. Let's say I was just using AWS just because I know AWS is the best of all the services. So what I do is, you'd have your data lake, you'd have your data go into S3 in the data lake, and then maybe on a daily basis you'd have a step functions pipeline run, and the step functions pipeline could use something like Athena to actually query the data out of the data lake, do whatever transformation needs to, and then store the data back into either the data lake with an S3 or in something like Redshift. And then from my, like, let's say I have like a machine learning API running, then I could have it query that data with like a timestamp and an entity, or not even just a timestamp, but like a range of timestamps, to then get that data, and then I would have to do the joins myself. So I mean, it wouldn't like I could do it like, but this does kind of make it a little bit easier if I understand how all this stuff works. All right, so you can see we have the data sources here, Redshift, Parquet file source. So this is one thing that's also kind of throwing me off is like it's showing sources here. Like these are like actual databases. Parquet is not really a file source. I mean, it is a file, but you can have Parquet stored locally. You could have it in an S3 bucket if you're using AWS, that is, things like that. And then the offline stores. Okay, so now let's just click into here. See the Parquet file source here. All right, file data sources allow for the retrieval of historical values from files on disk or for building things. Okay, so blah, blah, blah. So it's getting this from here. I don't see why you couldn't have like a Parquet file source that's just sourced from, the file URL. This file URL looks like it's getting it from local, but I don't see why you couldn't have it stored from within S3. Or an HTTP source, okay. Community plugin, online store. Okay, so the online store, these make sense that you would load, because you'd want so online, okay, I understand what offline or online kind of means here is that you want something where you can quickly get data from. And so like, obviously, if I'm running a real-time API and I need to get information from the feature store, trying to get it from like Redshift isn't going to be the fastest. A faster option is going to be Redis or DynamoDB. Data store is a GCP service, and then we got Azure, so that makes sense. But let's just look at DynamoDB. So DynamoDB is AWS's NoSQL database. Okay, so you can see here, All right, when I do my YAML, I'm doing a project My Feature Store. Registry is going in local. Provider is going to be on AWS, and you can see that we're going into DynamoDB US West 2. I'm also very curious how this would all integrate with Terraform, but that is another topic for another day. All right, so we need to define the permissions. So that's what these are. These are IAM permissions here. And okay, so all right. So I'm trying to remember. Okay, so how was this thing applied? So we did the init, right? It was the init. Let's go back and look. So feast init feature repo. Okay, so it does the init, but where did it make use of the YAML file? Okay, so the YAML file is there. Okay, and then we are reading the data from the Parquet file. Okay, fine. And then okay, so we're not just doing an init, we're also doing the apply. Okay, so the apply is what gets the feature view up in there with the YAML, right? I think. Okay, wait, all right. Right, okay, there we go. Yes, it is saying that. Okay, yes. I think you could, I don't know. All right, so I got too many tabs open. All right, providers, local. So I might try this again later this evening after the stream ends to see if I can get this all working locally. Because sometimes when I, not to say that this is a bad option, but like this is super nice, of course. But sometimes when you do things locally, it kind of clicks a little bit better because then you can explore the directories and stuff a little bit. Like I'm not even sure within Google Colab here how I can look at the file system things. Like can I, all right, view resources, manage sessions. Like how do I look at the directory structure? Is that here? Okay. No. All right. Maybe we can look at it here. All right. So we can see the sample data. None of that's relevant. All right. So in this feature repo, we got the data. So it created this Parquet file and these other DB files. All right. Example.py. All right. Example.py. So this is a feature definition. Well, I'm curious. Can I download this? Oh, I can download those. Driver stats. Okay. So let's see if I can, well, it's already 3:07. My dad's going to be here soon. Let me check my text too. Yeah, he's on his way. Gosh darn it. All right, we're out of time. I need to help out my dad with some stuff. So this stream didn't go as well as I thought. And that's okay. That's why we learn things together. So I don't consider this a failure by any means. If anything, it kind of gives, it kind of shows the process of like what I go through to try to understand a new thing is, if there are tutorials, I'll try to use the tutorials. This one's a little bit confusing because I don't understand like what the data set means. And so that's my own, like a lot of this is going to be my ignorance. So this is a lot of this on my bad. If I have one piece of constructive criticism for this tutorial is that it defines what that data is doing. Like, cause I still don't know what ACC rate is. And I don't really even know what conversion rate is in this context either. So that would have been more helpful. And maybe I can figure out how to do this with some other data that I already have. I don't know. Yeah, but for now, we are going to go ahead and end the stream. I hope you all still learned something today. Apologize if this was really confusing, but we learn through things together, we make mistakes together, and that's how we grow. I hope you all have a wonderful weekend. My lovely wife's birthday is tomorrow, so we're going to go out Christmas lights looking because that's what she really wants to do. It's a great time of year to do that. So for those of you living in Bloomington, by the way, we went to the Peoria lights. It's called the East Peoria Festival of Lights the other day. It's like this drive-through thing where you like look at these Christmas lights. I have 3 and 4-year-old daughters. They loved it. $10 a car. They accept card. And it's actually on like the south side of Peoria. So if you live here in Bloomington, it's like the closest place you can get to from Bloomington. So it's super easy. It's like a 35-minute drive. Highly recommend. In 2 weeks, we will not be doing a stream on Friday because I will be going to Chicago and taking my daughters to look at lights up there as well. There's another drive-in thing, and then there's like this arboretum thing where you can actually walk around and look at lights. So that's going to be pretty cool. So I won't be doing a stream in 2 weeks. I think we'll be doing another stream next week. It's definitely not going to be on Futures Tour. I think because I want to finish. The reason we didn't do the movie ratings model again today is because I'm doing a little bit more upfront prep for that one, and yeah, so I just wasn't ready for that yet today. So again, still hope you all enjoyed the stream. Thank you all for joining. Hope you have a wonderful, wonderful weekend, and we'll see you